Tyler James. Right? Tyler James? Yeah. You excited for today's lesson? Yeah. All right, let's learn about inverse trigonometric functions. I'm going to just, we could spend probably about, 4 or 5 days on this. We're going to spend one day and try to get to the main points. We talk about the sine function. You're familiar with the sine function looking something like that, right? Now, what we want to do is we want to find the inverse of the sine function. If you remember from quarter 1 and 2, we talked about y equals, say, 3x plus 1. What did we do to find the inverse of y equals 3x plus 1? Yep, flip the y and the x's. So we had x is equal to 3y plus 1. So we got x is equal to 3y plus 1. Well, and then we would solve for y. Well, it's really hard to kind of switch values here for sine. If you have y is equal to sine of x, if you switch those values, you get x is equal to a sine of y. And the question is, how do you get rid of a sine? Some people would say you divide by sine. No, you sine inverse both sides. When you sine inverse both sides, you get y is equal to sine inverse of x. There's another way to write this. You could write y is equal to arc sine of x. Those mean the same thing. Let's see if you remember this. In order to find the inverse of a function, it had to be one-to-one. One-to-one meant that it's a relation which every element of the domain corresponds with exactly one element of the range, and every element of the range corresponding with exactly one element of the domain. In other words, a function has to pass what test? Vertical line test. And a one-to-one function has to pass the horizontal line test. Does this sine function currently pass the horizontal line test? So if I draw a horizontal line, does it pass the vertical line test? But it does not pass the horizontal line test. So here's what we say. If we drew this sine function, if we just, drew the function as though it looks, go on forever, then the inverse would look like this. But is the inverse, is that a function? No, so what we have to do is we have to restrict the domain. We got to cut off certain parts of it. So what we do is we cut it there and we cut it there. Does that pass the horizontal line test now? It does. And so the resulting feature that we get is just going to be that portion. I know that looks odd, but that's what we have to do. I have to restrict the domain. So when I look back at my previous notes, the sine function, I've got to cut it there, and I've got to cut it there. And when you look at the new function, here's what you get. You get a function that looks like this. That's it, flipped over the line y is equal to x. Yeah, it kind of looks like the cube, but it stops. Take out your graphic calculator. Go watch the movie Meru. Good movie. Documentary. Climb a mountain. Okay, so I'm going to look at sine of x, and I'm going to work in radians and sine inverse of x. And I'm going to make sine inverse of x bold. And you got to change it to radians. It won't graph very well. And so then I'm going to zoom decimal. I'm going to zoom as 4, and we'll see what we get here. So you can see that this is the sine, this is the arc sine function in bold right there, right? Okay. And what you can see from it is that you have a section of that sine function that's reflected over the line y is equal to x. Well, let's talk about just a little bit more here. If you look at this portion of the sine function, this spot right here is negative pi over 2, and this spot right here is positive pi over 2. And it goes to a height of 1 and a minimum of negative 1. So that means that the domain is negative pi over 2 to positive pi over 2. What is the range? Negative 1 to positive 1. Well, when we do inverses, what happens? The range becomes a domain, and the domain becomes the range. So the domain here is going to be negative 1 to 1. And the range is going to be negative pi over 2, positive pi over 2. So that's negative 1. That's positive 1. That's positive pi over 2. That's negative pi over 2. That's a graphical representation, and I guess an argument for you to understand the nature of that function. Again, it's a function that's very kind of short, segmented, but we use it. Can I make this really plain and simple to you? I'm going to make it plain and simple. Okay? I'm going to quick work in degrees, and I'm going to do this. The domain is negative 1 to 1. What does that mean? If I do sine inverse and I plug in a number between negative 1 and 1, give me something. 0, okay. I get an output. Give me another example. 0.5. Negative 0.5. As long as I plug in values between negative 1 and 1, I get outputs between negative 90 degrees and positive 90 degrees. Are these between negative 90 and positive 90? Watch what happens when I plug in a value outside of negative 1 and 1, like 1.01. I get a domain error. It can't handle that kind of a value. Did we already know that? Yeah. The difference is now we're recognizing this as a function, and that's why it spits out these values. Okay? Cosine's a little bit different. The cosine graph, you guys remember it looks something like this, right? Is that 1 to 1? No. So in order to make it 1 to 1, what they do is they chop off this part of it. Now is it 1 to 1? Yeah. And when you look at the arc cosine function, the graph looks something like that. You don't have to graph it, but I'm going to just show you. I do cosine of x. Yep. Cosine inverse of x and cosine of x. Load, radians, zoom, 4. That's my arc cosine, and that's my cosine graph. Okay? What do you notice about the arc cosine graph? What's interesting about it? It's always above the, which means it's always positive. So it doesn't matter what you plug in. Whatever you plug in is going to come up positive for arc cosine. Cosine get out of there. Cosine inverse of 1. Cosine inverse of negative 0.2. Cosine inverse of 0.89. You always get all positive values, don't you? Cosine inverse of negative 1.3. Will that work? No. Because your domain, again, has to be between that negative 1 and that positive 1. And instead of spinning all values between negative pi over 2, positive pi over 2, we go from 0 to pi. We already kind of knew that, right? So this is trying to help you understand why your calculator works the way that it does. Finally, let's go to one more example. Let's just talk about the tangent graph quick. You guys recognize that the tangent graph looks something like that, right? Well, if we reflect this over the line y is equal to x, first of all, does that pass the horizontal line test? Yeah, it does. So what's nice about tangent is you can find you don't have to segment it. You can find a very nice inverse function. That's the arc cotangent function right there, or the arc tangent function, tangent inverse. Now, if you look at the black function, look at the black function for a second. Forget about the blue. Look at the black one. The black one has a domain from negative pi over 2 to positive pi over 2. But what is the range? Yeah, from negative infinity to positive infinity. So therefore, the arctangent function is going to have a domain from negative infinity to positive infinity, and it's going to have a range from negative pi over 2 to positive pi over 2. Sure, you can put all real numbers. And so what this means is that if you take tangent inverse of 0.5, you get a value. If you go tangent inverse of negative 0.5, you get another value. Do you think I could do tangent inverse of, say, 10? Yeah, you can. Look, the domain of arctan is all real numbers. And you're like, well, what if you chose a bigger one than that? What if you chose like 100? What if you chose a really big number? What's it approaching? It's getting really close to what degree? 90. Yep. It's a limit. So, yeah, so that's, you can punch in any value, and tangent doesn't discriminate there, okay? So, we're going to show you some cool things, okay? Number one, we want to understand why you get what you get. Well, we're going to do sine inverse of 1/2. You're going to do it on your calculator. I just want you to understand why you get the value you get, okay? Anybody know what you take the sine of to get 1/2? It's 30 degrees. But it works out that 150 degrees also gives you 1/2. For example, watch. If I go sine of 30 degrees, I get 1/2. If I go sine of 150 degrees, I get 1/2. But if I do sine inverse of 0.5, is it going to give me the 30 or the 150? It's going to give me the 30 because it spits out values between, negative 90 and positive 90. So that's why it gives you the 30-degree angle and not the 50-degree angle. You all good with that? Okay, let's look at the next one. Tangent inverse of negative 1. Do you know where tangents equal to positive 1? 45. It's negative 1 at 135, and it's negative 1 at 315 degrees. Well, it says that arctangent spits out values between negative 90 and positive 90. Is either one of these between negative 90 and positive 90? Does anybody know what it's going to give me? 315 is the same as negative 45. So your calculator, if you go tangent inverse of negative 1, you can see it's going to give you that negative 45 value. So all you have to be able to do today is type this into your calculator and understand why it gives you what it gives you. Okay. Can I take the cosine inverse of 3? No. If you try cosine inverse of 3, you can see I get a domain error. So you could say undefined. You could say no solution. Domain error, sure. Cosine inverse of negative root of 3 over 2. You guys told me that for this one you would get a positive angle. We get 150 degrees. Not too bad, huh? Now, at the bottom of this, I want you to write just 3 more quick problems. Right? Sine of sine inverse of 1/3. All right, cosine of cosine inverse of 7. Right, tangent of tangent inverse of 43. Sine and sine inverse are inverse operations. If they're inverse operations, what do? They cancel each other out. So what are you going to be left with here? 1/3. Now, at first glance, you want to do the same here, don't you? But can you do cosine inverse of 7? So technically, this is undefined because you can't take the cosine inverse of 7. So don't be so quick to cross them off. Now, can you take the tangent inverse of 43? Yeah. It's a really big number. It's like 89 degrees, but, you know, those cancel off. It gives you 43. Now, if you don't believe me, just take your calculator and go tangent inverse of 43. You can see that they're going to cancel each other, give you 43. See that? Can you handle that today? Okay, so let's do the part that is somewhat confusing, but the first example you won't get very well, but by the time we get the second one, you'll do great. Sine of cosine inverse of 1/2. Draw my triangle. We got to figure out what sine of cosine inverse. Those are not inverse operations. They don't cancel each other out. But what I'm going to do is I'm going to try to figure out by drawing a nice little right triangle with an angle of theta. So cosine inverse of 1/2 is just a fancy way of saying that the cosine of the angle is equal to 1/2, right? Well, in terms of opposite, adjacent, and hypotenuse, what is cosine? Adjacent over hypotenuse. Well, as we look at the triangle, this is my adjacent side. This is my hypotenuse. So I'm going to give the adjacent side a length. What should be the length? 1. What should be the hypotenuse? 2. Can I find the other side? Yeah. What do? Pythagorean theorem, 1 squared is 1 plus b squared is equal to 4. B squared is 3. B is equal to the square root of 3. Everybody with me so far? Here's the part where people get confused. This isn't magic. Just watch. Every time when we are solving for triangles, whenever you press cosine inverse or sine inverse, what were you trying to find? What were you coming up with? You're using it to solve for an angle, right? When you press cosine inverse, you got an angle. So if we do cosine inverse, what's our angle here that we come up with? Theta, right? Forget about the actual value. It's 60 degrees, but forget about the actual value. We get theta, right? So when I cosine inverse this, I come up with theta. So this expression becomes, instead of sine of cosine inverse of 1/2, becomes sine of theta, because this thing gives you an angle. So now the question just becomes, what is sine of the angle? Well, what's sine of theta? Root of 3 over 2. Rain's coming. That's theta. We got sine inverse of 4/5. What's sine in terms of opposite, adjacent, and hypotenuse? Opposite over hypotenuse. That means my opposite side is 4. My hypotenuse is 5. What's the other side? She said it? What'd you say, Terry? 3. Because it's a special Pythagorean triple right triangle. 3, 4, 5. Cool. Well, if you do cotangent of sine inverse, if you do sine inverse of something, what do you come up with? Come up with theta. Cotangent is not going to be opposite over adjacent, but rather adjacent over opposite, so 3/4. Not too bad the second time through, right? Got theta, got a 90-degree angle. What's secant? Hypotenuse over adjacent. So what should I label the hypotenuse? 3. Adjacent? 1. Can I find the other side? Square root of 8, or 2 roots of 2. Well, SOHCAHTOA. Cosine is adjacent over hypotenuse, right? Secant's going to be the reciprocal of that. A squared plus B squared is C squared. Pythagorean theorem. Yes? Okay. All right. If secant inverse is going to give me an angle, I have the tangent of theta. Tangent is going to be 2 roots of 2 over 1. Couple raindrops. Cotangent, adjacent over opposite. Adjacent is 12, opposite is 5. Anybody know the hypotenuse? 13. Terry, did you just memorize Pythagorean triples? Oh, okay, all right. We were impressed. We still are. Pythagorean triples? You can bring Mr. Durbin in here, you could show you. Or Miss Hanson. Yeah. You just multiply it by 2 or multiply it by 3. There's another set. 5, 12, 13. There's another set. 7, 24, 25. There's another set. 8, 15, 17. I'd keep going for you. All right. So if we do cotangent inverse, what do we come up with? Come up with theta. So now we're going to take the cosecant of theta. Well, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So we're going to do hypotenuse over opposite. Cool. I've seen ACT questions like this. Yesterday made sense. Yep. We had 2 days in a row. Hey, I'm trying to help you guys out, okay? All right? There you go. I do not have a homework cover sheet printed for you yet. I have one for previous years, but I haven't decided the exact assignments for the next couple lessons. So, you could also just go online to the website and check box those assignments. It's hard to keep track. What were you doing in college when they don't even write the assignments on the board? You'll cry. You'll just drop out. I had to drop out not because I wasn't smart enough, but because I don't know how to use the interweb. Broad shoulders? Just say broad shoulders, and we know what you're saying.